Hello guys, this is Mrs. Denton with Lesson 1-6, Rewriting Equations and Formulas, Pre Algebra. Go ahead and grab your notebook paper and put your heading on there. Again, Lesson 1-6. And we're going to practice rewriting equations and formulas. For your warm-up, you have 4 problems. The directions are simply solve the equation. I'm going to go ahead and give you time to pause the video so that you can work out all 4 of these problems and then come back and check your work and see how you did. Okay, let's look at number 1 here. So we have n subtract 4 equals 3n plus 6. Now, as you can see, we have variables on both sides of our equal sign. So before we can begin the process of solving, we need to combine our like terms. So I can combine the variables, I can combine the constants. I'm going to go ahead and start combining my constants and get rid of this -4 by adding 4. Whatever I do to one side, I must do to the other side. Now I'm left with n equals 3n plus 10. At this point, again, I still have my n variable on both sides. I want it isolated, so I want to move it to the opposite side as my constant. If I look at the right side and I focus on the 3n and I want to undo that 3n or move it, I'm going to have to pair it up with its opposite, which is a negative or subtraction. That allows me to cancel it out or make a 0 pair, and whatever I do to one side of the equal sign, I must do to the other side. Now, when we're looking at the left side here, we have n subtract 3n. You can think about that as a positive 1. So if you need to put it into your calculator, you would enter in 1 subtract 3. That's going to leave you with a negative 2n. We're going to bring down the 10 on the right side of the equal sign. Now we have a one-step equation that we're going to use the division property of equality to solve. And once we divide both sides by -2, n equals -5. Now, our other strategy, if we want to talk about that as well, let me take the problem n subtract 4 equals 3n plus 6. And let's say we want to move our -4 and move our 3n as well. So if we make those moves, then we're left with n. Remember, once we cross the equal sign, our sign changes. So 3n becomes -3n. Put our equal sign there. We had a 6. We moved our 4 across the equal sign. It was a negative. Now it becomes a positive. At this point, I have my like terms on the same side. So I can simplify n subtract 3n, leaves me with 2n equals 10. Divide by -2 on both sides. Simplify, n equals -5. So either way, you do not have to solve it both ways. Now, looking at number 2, on number 2, we have parentheses. So outside of the parentheses, I have 3/10 in decimal form, parentheses W plus 10, parentheses, equals 1 8/10 W. The first thing that I need to do is to get rid of those parentheses by distributing the coefficient of those parentheses. So once I multiply 3/10 times W, here's my new equation, 3/10 W, 3/10 multiplied by 10, and these are positive, gives us 30. And we simply bring down 1 8/10 W. Now I have my W's on both sides, so I need to combine those like terms. I'm going to move this one on the left so that 30 is by itself. It's a positive 3/10, so I'm going to pair it up with a negative or subtract. I'm going to have to do the same process on the other side of the equal sign. Now I'm going to bring down my 30 equals, and I'm going to put into my calculator 1.8 subtract 0.3. And that simplifies to 1.5 or 1.5 W. At this point, I'm going to undo the multiplication with division. And I'm going to divide 30 by 1.5 as well. Put that into your calculator, and you should get 20 equals W, or W equals 20. Now I'm going to show you the other strategy, the OR. So if I were to take this same equation, 3/10 W plus 30 equals 1.8 W after I've already distributed, I know that I'm going to need to move these terms. So if I take the 30 and I move it to the other side, and I take the 1.8 W and move to the other side, I get a new equation. And I get 0.3 W subtract 1 8/10 W equals -30. Remember, when you cross the equal sign, it becomes a different sign, or the opposite sign. Now I'm going to combine those like terms and get -1.5 W equals -30. I'm going to divide by -1.5 on both sides, and W equals 20. Both ways are correct. And I'm going to give you a second here if you need to pause it to write anything down. I'm going to go ahead and switch this to an eraser, and I'm going to show problems number 3 and 4 now. Okay, let's look at number 3. On number 3, we have -3x plus 15 equals 3 parentheses 5 subtract x. Okay, once I see these parentheses, that tells me that I'm going to distribute. So I'm going to take that 3 and multiply it by both terms. Now I have -3x plus 15 equals 15 subtract 3x. Now if you notice here, we basically have the same thing. So I have a -3x, a -3x. I have a positive 15, a positive 15. Both sides are equivalent. And if you will remember when we talked about some of those special solutions, when we have an equivalent side, we know it is true or equal. We call that infinitely many solutions. And you can also see the infinity sign with that type of answer as well. That tells us that any value that we replace x with is going to end up being a true or equal statement in our equation. Okay, looking at number 4. Okay, on number 4, we have 1/2 parentheses 4x plus 14 equals 2 parentheses x subtract 7. Okay, I've got parentheses on both sides, so I need to distribute on the left side, distribute on the right side. Okay, 1/2 of 4x is 2x. 1/2 of 14 is 7. 2 multiplied by x is 2x. And 2 multiplied by negative 7 is negative 14. Okay, I'm going to start solving this problem by subtracting 7 from both sides. That leaves me with 2x on the left side equals 2x. When I put in negative 14 subtract 7 into my calculator, I'm going to get a negative 21. Now my next step is to combine my variables. So I'm going to take away the 2x on the right side. Whatever I do to one side, I must do to the other side. And as you notice, this also makes a 0 pair on the left side. So I'm left with a 0 pair on the left side and negative 21 on the right side. Does 0 equal negative 21? No, it is not equal, not a true statement. I could say either one of those. So in this situation, we have a special solution called no solution, because we're left with something that is not true or not equal. There would not be any value that we could put in place of x to make this an equal equation. So that's why we say there is no solution. Okay, we've got a definition here. A definition for literal equation. A literal equation is an equation that has 2 or more variables. So you're going to see 2 or more variables in literal equations. Okay, example 1. Solve the equation. 2y plus 5x equals 6, and we want to solve it for y. This is an example of a literal equation. So we want to isolate y and solve for y. Therefore, we want it to say y equals. Now, when we go to solve this equation, and I'm going to go ahead and rewrite it, 2y plus 5x equals 6. Our goal is to get y by itself. So we want to focus on moving everything except the y. So I want to get rid of this term 5x. I'm going to pair it up with its negative or opposite. or basically I can say I'm subtracting 5x. Whatever I do to one side, I must do to the other. Now, 6 and 5x are not like terms, so I cannot combine them. Want to make a note there, not like terms. 6 is a constant, 5x has the variable, negative 5x has the variable, so we cannot put them together. When we rewrite our equation now, we're going to have 2y equals, and it doesn't matter which one we decide to write first. I'm just going to go ahead and put the 6 subtract 5x. Now at this point we have a 2 as the coefficient of y. We want to get y by itself, so there's multiplication going on between the 2 and the y. We're going to reverse that with the division property of equality and divide by 2. Now when we come to the right side, we have 2 terms on this side. We have to divide both terms by 2. Now, I can simplify those terms. So my new equation would look like y equals 6 over 2, or 6 halves, simplifies to 3. And 5 over 2, which is, it is a negative, simplifies, well, it's already in simplest form, 5 halves. You might see it written as a decimal, 2.5. Same thing. We're going to move our x down with that. Now you could also see this written multiple ways. So if I were to reverse those terms, you might also see y equals negative 5 halves x plus 3, which is the same thing. That negative sign can be with the 5 numerator, with the denominator 2, or simply out in front in the middle of that fraction. Both are correct. Okay, example 1 continued. Let's talk about an extra example here. Solve the equation negative 2x subtract 3y equals 6 for y. So we're solving for y again. That's always important to remember. And I'm going to go ahead and write this down. So negative 2x subtract 3y equals 6. And we want to isolate y. So let's think about this as terms. I want to go ahead and get rid of this 2x so I can work toward my goal of isolating y. When I add 2x, I've created a zero pair. I'm going to come over here and add 2x. And remember, these are not like terms, so we cannot combine. So now I'm going to rewrite negative 3y equals, and it really doesn't matter which one we put first. I'm going to go ahead and put my 6 there since it was already on that side. Now, something else I want you to look at real quick. Anytime we are rewriting our equation and you have a negative sign in front of a term, that negative sign must move with the term. It doesn't just drop or go away. It has to stay with the term behind it. So that's why it's important to bring down a negative if it's a negative. Now, if it were plus or addition, you don't have to put that sign with it. Okay, at this point, again, I'm trying to isolate y, so I'm going to divide by negative 3. And when I go over to the other side of my equal sign, I need to divide every term by negative 3. That's going to put it in simplest form for me. So now I have y equals 6 over negative 3, or 6 divided by negative 3. simplifies to -2. And I have a positive 2x divided by -3. And that's actually going to turn into a negative. And 2/3 is already in simplest form. So I'm just going to move it down with my x. Now, this could also be written as y equals -2/3 x subtract 2. Same thing. All I did was reverse those terms. But as long as their sign in front of them is correct, it is the same answer. And once again, that 2 or that negative sign can go with the 2 in the numerator. It could go with the 3 in the denominator, or it simply could go out front in the middle of 2/3. All of these ways are correct. Okay, example 2. And I think I'm going to leave it on there so we can mark up this word problem. The formula for the surface area of a cone is, so we've got a formula right there. Solve the formula for the slant height L. So we are wanting to basically isolate the L from this literal equation. So I'm going to rewrite my equation, and it's a capital S because it's the surface area. And we have pi r squared plus pi r times the slant height, or L. Now that L that we're talking about is this distance right over here. So we're asking to isolate the slant height L. So a couple things that we're going to have to move. Now think about these like terms. So this would be a term right here on the left, and this second part would be a term as well. So I'm going to move the one that doesn't apply or have the L with it first. Now when I move that, I'm actually going to subtract it. Let me do that in a different color. So I'm going to subtract pi r squared, and I'm going to come over to the other side of the equal sign, and I'm going to subtract pi r squared as well. So now let's rewrite that. We have our S, subtract pi r squared equals pi r L. Now, what is going on between the pi, the r, and the L? Multiplication. So if we want to undo that, we are going to divide by the two terms that we want to move or get rid of. So if I divide those three, pi r L, by pi and r, I'm on my goal to isolating that L. Now I'm going to come over to the other side, and I'm going to divide every term by pi r. And in this example, I have two terms on the left side. Now, if you'll notice, this pi can also cancel out. Also, when we're looking at this, we have an r squared. Now, if you pay attention to that part, we have an r in the denominator. The denominator r is understood to have an exponent of 1. So if I have r squared and I'm dividing it by r to the first power, I'm actually going to be able to cancel out one of those r's because it simplifies. Dividing a number by itself equals 1. So now, with all of that taken out, I didn't change anything on the left side. So with the S over pi times r, now this second term has simplified now to just an r to the first power, or r by itself. Then we have the equal sign, and we bring down our L. So as long as we have our L or our slant length isolated, we have everything that we need. I could also rewrite that as L equals, and I could put that negative R in the front and then put the positive S divided by pi R. Both are correct. Okay, we have a mini assessment, and it says you try, solve the formula for the red variable. So we have 3 formulas here. The red variable is what you're going to solve for or isolate. Go ahead and take a minute, pause the video, work your way through these 3 problems, and then come back and see how well you did. Okay, I'm going to go ahead and show my work on these 3 problems, and I'm going to put number 1 up here at the top so I don't run out of any room. And I have the distance formula, which we talked about in a previous lesson with a word problem. D equals R times T. And we want to solve for the red variable, which is the R. So we're actually going to figure out what's going on where the R is located on the right side. R and T are side by side. That's telling us that they're multiplying. So I want to reverse that, and I want to divide. And I want to move the T away, so that's what I'm going to divide by. Now I'm left with D divided by T equals R. So as long as my R is isolated, I've solved for the red variable. Okay, let's look at number 2 now. On number 2, we have the formula for the area of a triangle. So we have area equals 1/2 base times height. And you can see that height is the variable that I'm solving for. So a couple things that I need to do on this one. First of all, I want to get rid of the 1/2. Now, it looks like they're multiplying 1/2 times base times height. So I could divide by 1/2. Cancel that out. When I come over here, I can divide by 1/2 as well. Now, if you'll remember back in 6th grade math, dividing by a fraction is the same thing as multiplying by the reciprocal. So I could also look at this as A times 2 over 1, which is the reciprocal of 1/2, and that would simplify to 2A. I really don't need to put 2A over 1 because that's not going to be how it's written. On the right side, I have my BH, and again, there's multiplication going on there. So in order to get H isolated, we're going to divide by B. I'm going to divide the other side by B, and now I have my H isolated, and I know that H is equivalent to 2A divided by B. Okay, let's look at number 3 now. The formula for number 3 is the circumference of a circle, and we have C equals 2 times pi times R, and we are isolating or solving for R. So our goal is to get R by itself. 2, pi, and R are all being multiplied. So I'm going to divide by what I want to get rid of, which is 2 pi. Whatever I do on one side, I have to do on the other side of the equal sign. So I'm going to divide by 2 pi on the left side as well. Now I've got r isolated, and I'm left with c divided by 2 pi.